We are going to start off with triangles today, and we're also going to start off with the old school triangle area that a lot of you probably will remember seeing. Does anybody think they know what a triangle formula is? Go ahead, Jonathan.
1/2 times base, right?
Yep. The formula is area is 1/2 times base times height. That's a B, not a 6. Triangles actually have multiple formulas for them. Some of them even use sine that we've talked about before, like it'll use a sine function on your calculator. Some of them use like the special properties of special right triangles. But the general form is 1/2 the base times the height. What we have to remember, and we're going to draw a couple triangles to the best of our ability, when I see a standard regular looking triangle, just a typical one, my base and my height will surround the right angle. The base and the height will surround the right angle. The altitude is that line that comes from one vertex and hits at a perpendicular on the opposite side. But if you remember, when we talked about altitudes a while back, and sometimes these are a little bit difficult to draw, we had instances where the altitude actually ended up being on the outside of the triangle. So we have to watch for our height sometimes being in a different location. And then other times, the height or the altitude is a side. So if I have a right triangle, then my height would be actually one of the legs of the triangles. One last kind of comment. It can be flipped any way. It's just whatever two sides surround the right angle. Okay? So these formulas are going to be pretty basic for today. What's my area? 1/2 times 10 times 7. Plug it in your calculator, get your area. Sometimes I might have to find the height using some of our tricks, like our Pythagorean theorem. I might be missing the altitude. Or SOHCAHTOA. If I'm given an angle and only one side, I might have to find the base and height. So sometimes we're going to have to do a little work for it. But when it's given, 1/2 times 6 times 4. One half times 7 times 25. That one's going to come out as a decimal. I would probably write it as 175 over 2 units squared. But you might write it as 87.5 units squared. I'd accept either. Did I do that okay? Did I do bad math? What's that? Right. Are you sure? You think you're okay? Yeah. Oh, that's fine. 87.5, 87.5, same thing. Yeah, this could also be written as 87 1/2. Okay. Oh, I know what you were going to say, Anya. Yes. I did make a mistake. What did I do? I need to find the height. I was even talking about that. Sometimes you're going to have to find the missing pieces. I didn't find my missing piece. I need the two sides to surround the right angle. Is that a triple?
Yeah.
Yeah. So what should this one be?
24.
24. So this should have been 1/2 times 7 times 24. That's 96, 94, 84, 84 units squared. Much better. Sorry about that. I could tell you're just were. You could. No, you were right. I'm glad you spoke up. Okay. So final answer on that one.
How you find the height?
What's that?
How you find the height?
The height I found by using, you could do Pythagorean theorem, or we have these Pythagorean triples up here, and I found one leg was 7 and the hypotenuse was 25, so the other one had to be 24. Do you remember looking at those? Good. Okay. What's that? Oh, okay. All right. Area of a trapezoid is a little more complicated. So I need, again in here, a height. And I need to know what the bases are. And the bases are the two parallel sides. That's a B. And our formula is 1/2 times the height times the sum of the bases. Basically what you're doing is you're averaging the bases and multiplying it by the height. That's what the base 1 plus base 2 divided by 2 part is. That's the average of the bases, half of that, and then times the height. So it's similar to a rectangle or a parallelogram, base times height formula. It's just that we have two different length bases, so we have to average those together. So let's go ahead and work our way through some practice problems here. This is 1/2 times 6 times 5 plus 9. So I get 3 times 14, or 42 units squared. So our next one is 1/2 times 4 times 14 plus 16. Order that you put your bases in doesn't really matter. So that's 2 times 30. I just kind of work through them separately. I do the outside and the inside, and I get 60 units squared. Sometimes, again, you're going to have to find some missing information. So in C, I don't have the H part of it. What is the height? 4. Are you guys magic? How do you know that? Yeah, it's a Pythagorean triple. It's a 3, 4, 5 problem. So this is 1/2 times 4. What are my bases? 14 and 6. Where'd the 14 come from? Yeah. So that full length here, I have to combine those together. So then that's 2 times 20, or 40 units squared. The last types of problems we have are the rhombi. And so the formula for the area of a rhombus is what we're going to go with next. Good? Okay. Here we go. Area for a rhombus. First of all, what makes a rhombus a rhombus? Oops. Try and do your best. It's like a parallelogram with all sides congruent. It turns out one of the properties of a rhombus is that the diagonals, that means from opposite vertex to opposite vertex, and I'm going to do these in different colors so they can stand out. The diagonals bisect each other. What does that mean, to bisect each other? Exactly in the center. Yeah, perfect on each side. So that means that one half of that in red is congruent to the other half that I drew in red. And likewise, one half the blue will be the same as the other half of the blue. Another property of a rhombus is that the diagonals also hit to form a 90-degree angle. So those things are going to be able to help us find missing pieces if necessary. Like maybe I need to find the perimeter, so if I look ahead to A, I know that I have two legs of a right triangle. I can find that hypotenuse by using the Pythagorean theorem because I know that's a right angle. But the formula is area equals 1/2 times diagonal 1 times diagonal 2. My diagonals are, again, if I look at a rhombus, here's one diagonal, I'd call that diagonal 1. In the same rhombus, the other one is diagonal 2. Sometimes I'm going to need to, like I said, use the properties. So if this piece here is 6, I know the other piece on the other side is also 6. If this side on the diagonal, if half the diagonal is 14, I know the other half is 14 as well. And so when I'm looking for my full diagonal, it's 1/2 times 28 times 12. The full length of the diagonals. How does 168 sound?
Yeah.
Okay. Again, like I said, on occasion I'm going to be missing information, but because I know that this intersects at a right angle, if I have the side of the rhombus, I can find this missing leg. Is there a 9 something 15 group up there? If I don't see it up there, then I'll do Pythagorean theorem. 9 squared plus x squared equals 15 squared. 81 plus x squared equals 225. Just doing the Pythagorean theorem, I subtract the 81. X squared equals, is it 64? No? 144. Okay. And so the square root x is 12. So I know this side is 12, making the other piece of the diagonal 12 as well. So just using Pythagorean theorem if I don't see that up there. One thing to point out when you're using Pythagorean triples, and we haven't really talked about that a lot, but maybe some of you will use this, maybe some of you won't. And that is because 3, 4, and 5 are Pythagorean triples, if I do the same thing to each of these, multiply, like do a common factor, double them, there's another Pythagorean triple. If I multiply that by 3, we see where the one we just talked about came into play. That doesn't always look obvious when we're working through them, but that will work for all of these. 18, 80, 82 will also be a Pythagorean triple because they have that common factor of 2 in that family. Okay? So 12 is what we get here. This is 1/2 times 18 times 24. Bless you. 2 what? 216. All right. So I have, in the last picture, they're making me do a little work again. They give me the full diagonal. I'll have to draw the other diagonal in. When I look at this particular triangle, or sorry, rhombus, the diagonals will cut each other in half. Yep, so this little piece here is 12. I have a right angle. It's 5. Good. So I have 1/2 times 10 times 24. You guys okay with my? Okay. $120 sound good? Okay. You guys feel okay with that? Make sense? Okay. All right. So we just have a couple more problems to do. These ones we're working a little bit backwards on. Does anybody need to get stuff down here? Are we good? Okay. So we're going to be working backwards on this. We know the area. We need to find the missing parts. This is where our algebra sometimes comes into play. I know that the area for a triangle is 1/2 times the base times the height. That's what my area formula equals. So this is telling me I know the area is 35. So that's 35 is going to equal 1/2. That's a constant that's always in there. I don't know the base, but I do know the height. So I'm going to rewrite this as 35 equals 5/2 x. How do I solve that? Yep. Times the reciprocal is definitely one way to do it. So I would multiply both sides times 2/5. Put my 35 over 1. That's going to cancel the 2 on the right, the 5 on the right, leaving me with just x. When I do this math, I can cancel or use your calculator, however you want to do it. But I got x equal 14. Is it 14 units squared?
No.
No, it's only 14 units. Now, other people may have done this problem or solved this problem a little bit differently. We get to the point where we have 35 equals 5/2 x. You could just divide by 5/2. So that would be 35 divided by 5/2 if you are a calculator worker, and you could get the same answer. Good? You could also do 2.5. Yeah, because 5/2 would be 2.5. Yep, for sure. Okay? So however you need to math through that, that's how you need to do it, and that's fine with me. All right, here's our next one. I have the area, and area is equal to 1/2 times the height times the sum of the bases, base 1 plus base 2. So I have the area, 80, is 1/2 times the height times base 1 plus base 2. Those bases that I put in there are interchangeable. I could have done x plus 13. But how do I solve something like this? What's my first move? Yep, 1/2 times 8, so 80 is 4 times 13 plus x. What's my next move? Keep going. Distribute that through. So 80 is 52 plus 4x. Remember all this solving stuff? What's my next move? Minus the 52. So I have 28 equals 4x. I gotta move over here. Finish that off. At this point, I think you guys have solved enough equations, hey, at nauseam almost, in your career as a student. What's that? You have homework, yeah, why? Why, what made you think we don't have homework?
I just want the homework.
Oh, it was just wishful thinking? Okay.
Because it's Friday and we don't want homework for the weekend.
Yeah.
Yeah.
I work all weekend.
So do I. I don't have enough work to do for
All right, area equals 1/2 diagonal 1 times diagonal 2. Let's go ahead and put this in. I know the area, 182, 1/2 times, what's the length of diagonal 1? 14. And diagonal 2, I don't know. Actually, they told me it's x, so I'll put x in that spot. So 182 is 7x. $26? Yeah. 26 units. Let's just do a quick summary of the formulas that we've used so far so we have them down in front of us in a spot on our notes. What's a square? Base times height, we write it as side squared. All I need to know is one side, side squared. What's a rectangle? Base times height, length times width. You can write it either way. What's a parallelogram? Base times height, it's the same. What I have to remember on a parallelogram, though, is my height is on the inside usually. What's the triangle? Beautiful. Those are B's. What's the trapezoid? There we go. Okay. And rhombus? Good. So you have all the formulas that we've used. Remember, you don't have to memorize these. You just have to know the shapes, know which one to use. Okay? So here is your homework that you've all been waiting so patiently for because you love homework and practice. I hear the cheers. Calm down on the cheers. Oh, I forgot to turn it off in my all the time.
Well, they all yours too.
Yeah.
So listen.